So we are mostly proposing new technologies to actually get access to the metal value. And the metals can be metals that we use for infrastructure, like iron and steel. How do we get iron in a way with less energy consumption, with less CO2 emissions, with less water emissions? Or it can be also critical elements that are used, for example, in new technologies, like the rare earth elements or elements that go in semiconductors, which are fairly rare from an abundance standpoint, but for which we also don't really have good technologies to harvest them in a sustainable way. So we are not trying to say we're going to do material science of designing new materials for the future. What we're saying is that we know that engineers will use more and more of all of the elements. How we're going to get these elements in a more sustainable way is what we're going to try to tackle. The importance of metals and minerals in the future of the planet cannot be denied. We have seen what happened in the growth of China, for example, which has driven the demand for more and more steel. Steel is one of the best materials you can use to make bridges, to make rails, to make infrastructure in a cost-effective way, in a durable way, as well as in a sustainable manner. Now, that doesn't mean that we cannot do better. We've seen that the huge increase in demand has led to huge transportation, for example. There is an impressive amount of raw materials which are moved around to allow to get access to these metals, which ultimately allows lighter cars, better building, better infrastructure, but during their extraction are actually impacting fairly negatively the planet. So in order to reconcile the future of metals and minerals which are necessary for the environment, we have to think, how do we get metals and minerals? And that's only if we consider these two approaches that we will be able to provide a sustainable future for these industries. So upstream of the supply chain, we have the extraction or the mining of the minerals that are going to be necessary down the road to get access to the metals. During this step, there are some geologic reality, there are some physical reality that requires to separate the valuable minerals from the other minerals. This step is called concentration or beneficiation most often, and is done with technologies that were developed a very long time ago. One of the difficulties is that we want to maximize the recovery of the valuable minerals, which requires actually to have more efficient technologies. And here is the first opportunity to basically increase the value that you can extract from a mine is by having a technology that allows to recover maybe 1% more of the copper value that is in that ore. This is where the MME program allows to actually tap into the knowledge of the chemical engineers, the chemists, the people in physics, the people in mechanics who have developed some new arrangement of chemicals and physical realities in order to extract better elements, very often not focusing on the mining problems, but however with approaches that could be very relevant for these existing operations. So developing new recovery methods would be a clear path in order to increase the value of the existing mines, and at the same time will actually reduce the amount of waste that you would generate per ton of minerals that you extract. So we have here a clear win-win situation where if we were to develop these new approaches, we would actually increase the value, the actual cost value of the operations, but also reduce the amount of waste that will have to be generated.